Hi, good evening to all. Am I audible to all of you guys? Uh, can anyone respond me whether I'm audible to all of you guys or not?
Yes,
Okay,
Vikas, you are audible.
okay, great. So guys, in yesterday's session, I got queries related to how to install Anaconda Jupyter, how to use the Jupyter notebook, how you can open the Jupyter environment and all. So for that, I request Amar to share a link. It's a YouTube video link. You can follow that particular link, how to install Anaconda, how you can utilize the functionality of Jupyter. Right. So I will request Amar to share that particular YouTube link over the chat box.
Yeah, I'm sharing that.
Yeah, thank you. Okay. Meanwhile, let me share my screen. Okay. I'm sure my screen is visible to all of you guys. Okay, good. Thank you, Amar. Thank you very much. So guys, today's topic is related to the natural language processing. In short, it is also called as a NLP. Natural language processing. It is one of the specific application of the machine learning as well as the deep learning and AI. So the same concept you can also find out in the machine learning part. The same thing you can see using the deep learning or AI portion. So today we will try to explore a few basics things related to the NLP part so that you guys will get comfortable with respect to the different terms and terminologies related to the NLP part. And then we will try to explore few programming part, I mean the things related to the programming with respect to the NLP, how you can handle the this kind of problems, right? So let me start with what is the NLP, what is the natural language processing. So actually guys, it is one of the specific application of the machine learning, and this particular part deals with the text data. Text data. So the data which we saw yesterday, that was the numerical data. If you guys recall, yesterday we have discussed one kind of a data where we have a features like rank, discipline, salary, PhD thesis, those kind of things, service years. So that was the numerical data. And yesterday we saw how we can handle the numerical data using the Python. Now today's topic is if you're getting the text data. Now this text data, it can be a form of the reviews given by the users. It can be the feedback. It can be tweets, right? Or it can be chatbot conversation. It can be any kind of a text data which we are getting from the different platforms in a different manner. So how you can handle that text data using Python? So this particular field is called as a NLP, natural language processing. All right. So ultimately, NLP is nothing but the use of computational methods and techniques to extract the high quality information from the text data. So under this NLP part, we are using the different kind of techniques as well as some computational methods And what these techniques and methods will do, they will extract the hidden information from your text data, right? Since this time the data is not a numerical form, so the handling of data is little bit different from whatever we have saw yesterday, right? So this particular part is also called as a text mining or text analytics. Text mining or text analytics. It is also called as a NLP or text mining or text analytics. So ultimately, you are going to handle the So there are a lot of applications nowadays coming in different domains related to the NLP part. So one of the application is document classification. What is this document classification? So as its name suggests, you need to classify the documents based upon its behavior. So let's suppose, guys, in a particular department, we have a different kind of a documents. Let's suppose there are few documents related to the let's suppose finance domain. We have a certain kind of a documents related to the sports. We have a documents related to the let's suppose some educational blogs. So likewise, we have a different set of documents. And let's suppose in future, we are getting some new kind of a document. So how I can leverage the functionality of NLP so that it will classify this particular document, whether this document belongs to the finance kind of a document, or it is a sports kind of a document, or it is a educational kind of a document. So this is something called as a document classification, and that is done by the with the help of the NLP techniques. Right, since the documents is in form of the text information, so we are leveraging the functionality of the NLP. Other utility is clustering the documents or organizing the documents. Document summarization. Document summarization is nothing but, in a short, let's suppose, guys, we have a research paper, and I'm sure all of you guys know research paper. Like the language of the research paper is very. It's not a simple language, right? So it's written in a very set predefined format. And let's suppose we have a research paper of, let's say, 20 pages. Now I want to summarize the important key concepts with respect to this particular research paper, rather than going to all the 20 pages and reading it line by line. So here also we can leverage the functionality of NLP. I can use the concepts of the NLP over this particular research paper, and I can summarize this 20-page research paper into 1 or 2 paragraphs only, so that I can get the gist of this particular research paper. That is something called as a document summarization. Apart from that, we can use the different kind of a prediction models over these text data. It is also helpful in case of a recommendation system. NLP is also helpful in case of a content-based recommendation system. The other possible use cases of the NLP is virtual assistant. So I'm sure all of you guys know what is the Alexa, what is the Siri, Cortana. So all these are the virtual assistant, and they are leveraging the functionality of NLP only. All kind of a chat bots, email routers, classifiers. So all of these tools are using the concept of NLP. Even one of the most popular application of the NLP is sentiment analysis. What is the sentiment analysis? So basically, using this particular concept, we are analyzing what is the emotion or sentiment of the customer is. So let's suppose a particular customer visited to a restaurant, and after having the dinner or lunch, the customer gives the feedback. Now, this feedback is in form of the text. It's not a numerical data. It's a form of the text. Whether the food was awesome, or the service is good, or something like that. So what we can do, we can collect all those feedbacks by the different customers, and we can analyze, we can leverage the functionality of NLP, and we can get to know that what was the sentiment of the customer, whether the customer was happy, whether the customer was neutral, or the customer was not satisfied with the services. So that is something called as a sentiment analysis or emotional analysis. It is also called as a emotional mining. Emotion mining. All right. Another application of the NLP is translator. Actually, it is called as a machine translation. Machine translation. So what is this machine translation? Let me give you an idea what is this translator or machine translation is. So let's suppose, guys, we have a document written in French language. We have a particular document written in a French language, but I don't understand this particular language. So what I can do, I can leverage certain kind of NLP techniques. What these techniques will do, they will transform this particular document, which is written in a French language, into, let's suppose, English language. So this is something called as a machine translation, where I can utilize the concept of the NLP, and I can transform a text document from one language into another language. So that is something called as a machine translation. So these are some popular use cases of the NLP. In short, we are dealing with the text data, and over this text data, we are applying different kind of techniques and analysis based upon our requirement. Okay, so up to this point, we understood that what is the NLP and why there is a demand for the NLP. What are the different applications for the NLP? So these are the different applications of the NLP which deals with the text data. Okay, let's see a few technical details related to the NLP part. So yesterday we saw how we can handle the numerical data. But if you're getting the text data, let's suppose you are getting the data like this. You have a customer ID, customer 1, 2, 3, 4, and so on. And here we have a reviews. Reviews related to a particular product or particular service. So the reviews in the form of the text. So if this kind of a data you are getting, you cannot apply any kind of a statistical technique over the text data, because the statistical techniques are applicable only over the numerical data. Any kind of a statistical technique or modeling cannot be applied directly over the text data. So here the data handling is little bit different from whatever we saw yesterday. So let's understand what is the different data handling or pre-processing steps involved if you are getting the text data. Okay. So let me just take few comments and all. Just a minute. Okay. Okay, cool. Okay, let's see, guys, what are the different text data pre-processing part. But before getting into that, let me just give you an overview idea or top view picture what we are going to do. So let's say you want to perform a particular task A. It can be any of the tasks related to the your text data. Let's suppose the task A is build a model. Build a machine learning model over this text data. Now, I'm sure all of you guys know any kind of a machine learning model is a statistical model, and the statistical model can be applied only over the numerical data, right? So what we do, whatever text data we are getting. So let's suppose this is your text input data. This is your raw text input data. First of all, what we do, we apply certain kind of a pre-processing steps over this raw text data. It's a raw text data. Now, what this pre-processing steps will do over this text data, they will make this text input data as a clean data. There might be possibility that few abnormalities present in this raw input data. So we need to remove all these abnormalities from this raw text data. Don't worry, I will show you for the coding how you can do that, and I will show you what are the abnormalities and all. So first of all, what we do, we apply certain data pre-processing steps over this text data, and the output of this pre-processing step will be a clean text data. Clean text data. Once we get this clean text data, then what we can do based upon our task. So if your task is just to analyze your data set, so we can directly analyze the data, text data from this clean text data. So whatever clean text data you are getting, so using this text data, you can do your analysis, a simple analysis. Let's suppose you want to build any kind of a machine learning or deep learning model. Then you need to transform this text data into the numerical form. That means you need to generate the numerical equivalent of this text data. That is something called as a vector representation of this text data. Vector representation. Now, this vector representation is being done with respect to this text data using a different kind of techniques. I will show you a couple of techniques how you can transform your text data into the vector form. Vector form is nothing but the numerical representation. So here we are calling it as a vector representation, which is nothing but the numerical representation or numerical equivalent of your text data. And once we are getting this numerical equivalent of your text data, then over this numerical data set, we can apply any kind of a statistical methods or modeling. So this is the complete flow of this text data analysis or NLP part. Now, I'm going to discuss what all the data pre-processing steps involved when you are dealing with the text data. And let me clear you to all you guys. These data pre-processing steps are only applicable over the text data. You cannot apply these steps over the numerical data. So this kind of different steps and concepts are applicable over the text data only. Okay, so I'm sure this part is clear to all of you guys. If you have a doubt, you can put your doubts in the chat box or comment section. Okay, so let me start with the data pre-processing part with respect to the text data. Okay, so the first concept is called as a tokenization. There is something called as a tokenization. What is this tokenization? So basically, tokenization is nothing but it is breaking the documents or sentences into chunks. And each and every chunk is called as a one token. Each and every chunk is called as a one token. Let me simplify. For example, let's suppose I have this sentence. The sentence is the capital of China is busy. So what tokenization will do? It will break down this particular sentence into the chunks. And what are the chunks? So each and every word will become one chunk. And these chunks are also known as the tokens. So that means the first word is D. D is one token. Next word is a capital. Capital will be the second token. Next word is a off. Off will be the next token. China will be another token. Is will be the another token. Beijing will be the another token. So that means we are just breaking down the sentence based upon the space. So each and every word will become one token. This is something called as a tokenization. It's pretty much simple. Right? The second concept is removing the stop words. Removing stop words. Now, what are these stop words? So guys, stop words are nothing but the words that do not bear any information or meaning. The words that do not bear any information or meaning. For example, let's suppose I have a sentence like, this is not a good option. This is not a good option. So in this particular sentence, if you see, is this kind of a word doesn't contribute any information, right? So probably it's a review based upon some product or some like based upon some opinion. But if you see the individual words, if you tokenize this particular sentence and if you analyze each and every token, so this, is, and are, these are the three words which don't bear any information. So you need to remove these kind of unnecessary words, because if these kind of words are present in your text data, they will ultimately increase the complexity of your analysis. So that's why we will remove the words that don't bear any kind of information or meaning. Information is useful information. So that's why we are calling these kind of words as a stop words, and we need to remove these words. So the second thing is, so first of all, we have understood like what is the tokenization. Once we get the tokens, then we can analyze what are my stop words, and if the stop words are identified, then we can remove the stop words. Remove stop words. Okay. So once we remove the stop words, then what you can do, there is something called as a, just a minute, this. Yeah. Yeah. There is something called as a lemmatization and stemming. What is lemmatization and stemming? So let me simplify for you guys. Stemming is a process that chops off the ends of the word without considering its real meaning. That means if you're applying the concept of stemming over the tokens, right? So first of all, you got the tokens. Using that tokens, you have removed all the stop words. Now you have only useful words, or the words which contribute the useful or meaningful information. Now, over these kind of words or tokens, you can apply the concept of stemming or lemmatization. Now, what stemming will do? It will simply remove these suffixes like ing, es, or s, right? So these kind of suffixes can be removed by the stemming. Now, the drawback of the stemming is, while removing these kind of suffixes, stemming will not take care of its root word meaning. What does that mean? So let's understand through an example. Let's suppose, guys, I have 4 words: argue, argued, argues, and arguing. So over these 4 words, if you apply the concept of stemming, so as I told you, what stemming will do? It will remove these suffixes. So from arguing, it will remove the ing. From argues, it will remove the es. From argued, it will remove the ed. So what is left? The left part is a ARGU, but it is not the root word. There is nothing called as a ARGU. We have a root word as ARGUE. That is the correct word. So this is the drawback of the stemming. Stemming will simply remove the suffixes without taking care of the meaning of the root word. That is something called as a stemming process. And against to stemming, we have a something called as a lemmatization. What lemmatization will do? It will transform your words into its base form, or the root word. Base form or root word. Base form or the root word. So if you're applying the concept of lemmatization over these four tokens, the same tokens, so what lemmatization will do? It will take care of what is the base word or base form or the root word with respect to these tokens. So it will identify the base word is a argue. So it will transform arguing, argues, argued, all of them into the same root word, which is the argue. That is the correct form. So this is the difference between the stemming and lemmatization. Right? Just a minute, guys. Let me just take two questions. Just a minute. Yeah. So let me just take few doubts. Okay. Sure. I will repeat this part. Okay. So guys, tokenization is nothing but just breaking down your sentence into individual words. For example, let's suppose I have a sentence, the capital of China is busy. Just break down this sentence into individual words. Like D is one word, capital is another word, of is another word, China is another word, is another word, Beijing is another word. So after applying the tokenization, you will get the capital of China is busy. Each and every word has a one token. This is something called as a tokenization. Right? Okay. So yeah. So first of all, you need to do the tokenization. Then you need to remove the stop words. Then you can apply the concept of the lemmatization. Generally, we don't prefer the stemming. The reason why we don't prefer the stemming, I showed you here. Probably you will get the word which is not a correct word or not in a right root form. So that's why we prefer the lemmatization over the stemming. What lemmatization will do? It will transform your words into its root form or the base form. Okay. But apart from these steps, we have a few more things. Let me just show you through coding perspective what you can do. Just a minute. Let me share my screen. Don't worry, guys. I'm going to show you through coding part so that you guys can understand much better. Okay. I'm sure my screen is visible to all of you. All right. Cool. So before starting with the coding part, guys, let's understand a few terminologies here with respect to the NLP. So there is something called as a corpus and document. There are two terms. One is a document. Another one is a corpus. All right. You need to understand these two terms in a very crystal clear manner. So for that, let me just show you one of the data set first of all. Let's suppose, guys, this is my data set. What is this data set? In this data set, we have the reviews with respect to a particular product by different customers. So this is the review given by the customer one. This is the review given by the second customer. This is the review given by the third customer, fourth customer, and so on. So that we have a different reviews. So here you are seeing a couple of words here. So it's a big review. It's not a complete review you're seeing here. So that's why we have a 3 dots at the end. All right. So these are the different reviews given by each and every customer with respect to the particular product. So there, as I told you, there are two things. One is the document. Another one is the corpus. So document is nothing but each and every review is called as a one document. So that means the first review is one document, second review is another document, third review is another document. Likewise, we have a number of documents present in this data set. Let me repeat it again. What I told you, each and every individual review is one document. So if you see here in this data set, it starts from the index position 0 and it goes up to the index position 39. That means in total, we have 0 to 39 reviews. That means total 40 reviews. Now, as I told you, each and every individual review is a one document. So that means we have a total 40 documents present in this particular data set. All right. So each and every review is called as a one document. In total, in this data set, we have a 40 documents. So this is something called as a document. Then collection of all the documents is called as a corpus. That means this is one corpus, and in this corpus, we have a 40 documents. All right. So the corpus is nothing but it is a collection of all the documents. That is called as a one corpus. So this is what is written here. Corpus is a collection of all the documents, right? And the plural form of the corpus is called as a corpora. So these are the terms which are most frequently used in NLP. So you guys need to be very clear what is a document, what is a corpus, right? And then here I have summarized what are the different data pre-processing steps. So I have discussed removing the stop words. Sometimes you need to convert all of your text data into the lowercase. All right, removing the stop words I have covered. Tokenization I have covered. That means you need to separate your text or sentence into the words. I have covered what is the stemming and what is the lemmatization. So apart from that, there's sometimes you can find special characters or the punctuations present in your text data, like $, @ percentage, star, comma, semicolon, these kind of things. So you need to remove these kind of special characters or punctuations from your text data set. That is also a part of the data pre-processing. Sometimes you can find there is a presence of URL like www.something.com or .in, something like that. So you need to remove the URL also, right? Because ultimately these kind of things are not contributing much information to my text data. So these are some data pre-processing steps with respect to the text data, right? So you can follow these kind of steps to clean your text data so that you can remove the abnormalities present in your text data. Let me just show you how you can do all of these things, and then I will discuss few more concepts. So to perform these kind of tasks in Python, we have a package or a library called as a NLTK. NLTK. It is one of the most popularly used library in Python for the text related task to handle the text data. And the full form for the NLTK is a Natural Language Toolkit. Natural Language Toolkit. Natural Language Toolkit. That is the full form for this NLTK. All right. So first of all, you need to install this particular library to leverage the functionality of this particular package or library NLTK, and then you can utilize the different functions present within this particular library. Right. Let me just show you how you can install any package in the Python using like in the Jupyter notebook. So this is the syntax how you can install any of the library. So syntax is a pip install and the name of your package. Right? So this is a simple syntax how you can install any kind of a package or library within Python. Sometimes you can also use explanatory sign before this pip. That will also work. Right? So you can either use the pip install name of your package, or you can use explanatory sign pip install and the name of your package. Both will work. So here I have commented out these two things because I have already installed. But what you can do, you can remove this hash sign and make it uncomment, and you can run this one to install these libraries. Right? And there are certain dependencies are there. You need to also install these things. Word cloud is something different. I will tell you what is this thing. So you need to first of all install these things. How you can install? Just remove this hash sign and run this cell. Okay. I'm sure most of you guys know how to do that. Okay. So after installing all of these libraries, required packages and all, so here I'm importing the required packages. Right. So like NumPy, Pandas, Space is another package, word cloud, and all other things. So let me just show you what is our data set. So this is our data set. Let me just show you how it looks like data set. Just a minute, guys. Okay, I'm sure my screen is visible to all of you. So guys, this is our data set, what we are going to analyze. So if you see, this is the data set, that's a review data set. So here we have a different reviews given by the customers based upon the product purchased. So this is the first review, like it's amazing, battery lasts around 10 to 12 hours and so on. This is the second review. This one is the second review. That is a review given by the second customer based upon a particular product purchased. This is the third review. And so on. We have a different reviews present in this particular data. Right? So this is the text data, and we are going to analyze this text data using the concept of the NL. So first of all, I have imported this data set. And how to import a particular data set, we have already covered in the yesterday's session. So those who are not familiar with this part, they can go through the like last session recording. So here I have imported my data set, and these are the reviews by the different customers. In total, I have a 40 reviews, that means 40 documents, and this is one corpus. So in this corpus, I have a 40 reviews or the 40 documents. All right. Now let's see what we can do with respect to the data pre-processing part over this text data. So first of all, what I'm doing here, there might be possibility that while writing the review by the customer, there might be possibility that leading and trailing edges or spaces will be there. So what we are doing here, we are just removing the leading and trailing spaces if any present. So for that, we have a function called strip. So for each and every review, it will check whether there is a leading or trailing spaces are there or not. If the leading or trailing spaces are present, it will strip those spaces. Right? And then we are getting this output. So this is what we are doing over all the reviews. So this kind of a representation, can you guys comment it out? What kind of a data structure it is? It's a square basis. You can comment it out in the chat box or a comment window. What kind of a data structure it is? If it is a square basis, all right? So let me just see. Yeah, exactly. It's correct, guys. So it's a list kind of a data structure, and this kind of a representation, like inside the square basis, it's like X for X in the data set like books. This is something called as a list comprehension. It's a Python coding concept. That is something called as a list comprehension because it is a list data structure. Right? So what it will do, it will, using this list comprehension, it will check each and every review or feedback present in this book data set. And if there are any leading or trailing spaces are there, it will strip off or it will remove those spaces. This is first part. And this is the output what we are getting after removing the leading or trailing spaces. So this is my first review. This is the first review. This is the second review. This is the third review, and so on. Okay. Apart from that, what I'm doing here, so at this particular stage, I have all the reviews separated by comma. What I can do, I can combine all of these reviews into a single paragraph so that I can easily apply different kind of a data pre-processing steps. Right? So what I'm doing here, I'm joining all of these reviews into a single paragraph using the space. So using this space, join all the documents present in this book variable. So here you can see that up to this point, coders, this is my first review. From this, it's up to the coders. It's a first review. And then we have a space. And from finally, it is a second review. So likewise, it will join all of these reviews or documents using the space. You can also provide any other particular delimiter so that you can easily segregate the reviews. So in that way, we have got a single paragraph kind of a thing which joins all the reviews, all the 40 reviews. Okay. Then here we are just removing the punctuations kind of thing. I will show you how you can do that in a while. Okay. Now let's see how you can apply the tokenization, lemmatization, or how you can remove the stop words and all. So as we discussed, what tokenization will do, it will make your each and every word as a single token. It will break down your sentence and it will make each and every word as a single token. And if you see, now I have a complete paragraph as a one single review, right? I don't have a segregated documents or reviews. I have a one single review as a complete paragraph kind of thing. So what I can do, I can apply the concept of tokenization over this particular paragraph kind of data. So actually there are a number of tokenizers are present. We have a different tokenizers present under this NLTK library. But out of that, one of the most commonly used tokenizer is something called as a word tokenize. So it's a function which is present under the NLTK library. So first of all, you need to import the NLTK. Under this NLTK, we have a package called as a tokenize. within this tokenize, we have a method called as a word tokenize. So likewise, we have a different tokenizer. It is one of the tokenizer. All right. So we are going to utilize this particular tokenizer, which is present under the NLTK library, to get the tokens. So first of all, we are importing this particular method or function as a word tokenize. And then we are applying this method word tokenize over my last outcome. So this is my last outcome. I have saved this outcome as a no punch text. So this is the variable name where I have saved my last output. So over this output, over this variable, I have applied word tokenizer. And if you see the result, now each and every word is getting converted into one token. Here I have just printed the first 50 tokens. Right? So that's why you're seeing only a couple of tokens here, not all the tokens. So this is the tokenization. So if you see the input for that, so this was the input, right? It's amazing, battery last around 10, 12 hour best, like that. So now after applying the tokenization, I am getting each and every word as a one token. It's is a one token, amazing is another token, battery is another token, likewise. So this is something called as a tokenization. That means breaking down your text data or sentence into individual words. Okay. And then once we get all of these tokens, we can easily identify what are my stop words. Like if you see off is a stop word, for is a stop word. There is no useful information is contributed by these words or these tokens. Other, right? In, it's. So all of these tokens are the stop words. Now the thing is how you can remove these stop words. So for that, guys, same under the NLTK library, we have a dictionary. We have a dictionary called as the stop words. We already have a dictionary of the stop words, and this dictionary or this list is present in a different languages. So you need to specify in which particular language you want to import this particular list of the stop words. So first of all, you need to download this stop words. So nltk.download stop words, and then I want to this stop word list in an English language. And if you see what is this stop word list, so this is a by default stop word list present under the NLTK package. Right? You can directly leverage this particular list. If you see in this list, I have a words like I, me, my, myself, you, your, yours. And if you scroll it down, there are a lot of words are there, which are the stop words. You can directly utilize this particular stop word list to remove the stop words which are present in your text data. Right? There is one more functionality present with this stop words. Let's suppose there is a particular word, let's say D. D is a particular word which is a stop word, but this word is not present in this list. But I want to remove this stop word. So what you can do? You can add a particular word which you think it is a stop word into this particular list. How to add? Let's see. Let's suppose, guys, I want to add a particular word D, which I think that it's a stop word, but this word is not present in the predefined list. So I can easily add this particular word in the stop word list by using the method called as append. Yesterday we saw how you can utilize the append method. So it's very simple. Name of your variable, dot operator, append, and then the value. Here the value is a D. So what this append method will do, it will append this particular word in this stop word list. And whatever word you will append in this stop word list, all those words will appear to the bottom. That means at the last. So if you see the default dictionary, the last word is a wooden. It is the last word present in this particular list. After adding D, now D is being added in the last after today. Right? In that way, you can add any of the word which you think that it's a stop word for your analysis. You can add in this particular stop word list. I'm sure this part is clear to all of you. And then the thing is very simple. If you are sure that you are going to utilize this particular stop word list to remove the stop words, it's a very simple. You can use the list comprehension such that the words which are present. Okay, so you can read it like that. The words which are present in the text tokens, which are not present in the stop words. So just retrieve those tokens which are not present in the stop word list. So by default, you will get those words which are not the stop words. Right? So probably this particular word is not present in this list. That's why you're getting this hits. But if you see for, of, these kind of tokens are removed. Right? So it's very simple. The words which are not present in the stop word list, get me those words. So here we are getting that particular tokens. So the tokens which are not present in the stop word. Correct. Let me just take a couple of questions if you guys have. Yeah, sure. I will increase the font size. So leading and trailing edge spaces are nothing, but let me show you what are these. Okay. So guys, leading and trailing spaces are nothing, but let's suppose I have a review like this is good product, right? And then if I put a space after the product, this is something called as a trailing spaces. But if I put the space before this, let's suppose instead of starting from this point, I'm starting like this. I have put a couple of spaces before this, and then I have started writing. So this is something called as a leading space. And if I put the spaces after this product, let's say a couple of spaces, this is something called as a trailing spaces. So you need to remove these spaces so that each and every document or review is being aligned similar in a similar fashion. All right. So this is something called as a leading and trailing spaces. Let me come back to the Jupyter notebook. What are the other doubts? Yeah, it's a white space. Okay. Cool. So let me just increase the font size. I'm sure this much is okay for you guys, right?
Yeah, now it's fine.
Yeah. So guys, this is how you can remove the stop words from your text tokens. If you want, you can convert all of these tokens into a lowercase so that there is a normalization for all these documents or the reviews. So for that, we have a function called as a lower. So this function, what it will do from the previous output, which is this one, no stop token. No stop token is this variable name where I have saved this output, right? All of these tokens. So for all of these tokens, convert each and every token into the lowercase. So if you see the output, so let me just show you. Let's see this problems, this particular token problem. Now, after applying this particular list comprehension for the lowercase, now you get the problem, the P. If you see the P here, before applying this lowercase, the P was in caps. Now it is in lowercase. So likewise, like this news literally. So and this finally F. So all of these things converted into the lowercase. All right. So that will make the consistency across all the documents or all the reviews. You can also apply the stemming. So just like a lemmatization, we have a something, or tokenization, we have a something called as a stemming operator. So we have a different kind of a stemmer present. One of the stemmer is a Porter stemmer. So this Porter stemmer is present under the NLTK library. So under the NLTK, we have a package called as a stem. Within this package, we have a method Porter stemmer. And the process is same, how you can apply this particular Porter stemmer. So for each and every word in the lower case words, so this lower words is the variable which we got from the previous step, apply the concept of the Porter stemmer. So it will do it will just remove the suffixes from your token. So as I told you, generally we don't prefer applying the concept of stemming. We will prefer rather than lemmatization, because lemmatization will guarantee you to convert the particular word into the root form or the base form. Root word. Right. I will show you how you can apply the lemmatization, but this is just for your information purpose. You can go to this part. Okay, let me come back to the PPT. Okay, so tuples and list I have already covered in yesterday's class, right? Okay, guys. So these are the some data pre-processing steps with respect to your text data. Now, sometimes, as I told you, you need to apply certain kind of statistical models or techniques over your text data so that you can build a predictive models. For that, you need a numerical representation of your text data. So there are a couple of ways how you can transform your text data into the numerical equivalent. So that is something called as a vector representation of your text data. Vector representation of your text data. Let's see what are these things. So the process is called as a vectorization. Process is called as a vectorization. And whatever numerical representation you will get, that is something called as a vector representation. Okay. Let me just discuss you what other things are there. So actually, there are a couple of methods available to transform your text data into the vector representation. One of the method is a binary weights. There is another method called as a bag of word approach. It is also called as a count vectorizer. Count vectorizer. There is something called as a TF-IDF vectorizer. So these are the couple of approaches are there, which you can leverage to transform your clean text data into the numerical form or vector representation. Let me just discuss you what are these approaches and how you can leverage these particular methods. So, okay, in order to get into that part. Okay, so actually vector space model is nothing but it is a concept of vectorization, how you transform your text data into the vector representation. Now, once you, let's suppose you have transformed your text data like this, these documents into the vector form like this. So what happened? So here, when you transform your text data into the vector representation, the representation you will be getting in a form of the matrix. It's a form of the matrix. So it's a huge matrix where you have a number of columns as well as the number of rows. Now, what you have over these columns? So over these columns, we have the document number. That means, let's suppose document 1, document 2, document 3, document 4, and so on. The number of documents you have in your clean text data. Let's suppose we have an n documents. And over these rows, we have all the unique tokens. On the row side, you have the unique tokens. So the first token, second token, third token, fourth token, and so on. So all the unique tokens we have over the row side, and the document number like D1, D2, D3, these things you have over the column side. So this is the structure you are getting in a form of the matrix once you transform your text document into the vector representation, right? So this particular arrangement where you have all the tokens over the row side and the document present over the column side, this representation is called as a term document matrix. So what is a term document matrix? All the terms or unique tokens present over the row, and all the documents, document 1, 2, 3 like that, they are present over the columns. So this representation is called as a term document matrix. So for example, you can see here, these are my unique tokens like complexity, algorithm, entropy, traffic network, which we are getting from all these documents. So these are called as a terms or unique tokens. And this is the document number, document 1, 2, 3, 4, 5, and so on. So this kind of a representation is called as a term document matrix. You can transpose this particular arrangement. So if you transpose, what you will get? All the documents number over the column side, all the tokens over the row side. That means like this. So if you transpose this particular arrangement, so what you will get? All these documents D1, D2, D3, D4, D5 over the row side. So like D1, it's a D2, it's a D3, and so on. And over the column side, you will get all the unique tokens or terms. So like term 1, which is a complexity, term 2, algorithm, term 3 is the entropy, like that. So if that is the arrangement, this is something called as a document term matrix. Document term matrix. In short, DTM. Document term matrix or DTM. And this particular arrangement is called as a TDM, term document matrix. Right? So this is the difference between the arrangement of the terms and document number. And based upon the arrangement, we have the representation as a TDM or DTM. Right? Okay, so this is the representation. Now, within this representation, what are the values present in these cells? So the values is decided by what technique you have chosen. So as I told you, we have three techniques. One is a binary weight, another one is a counter vectorizer, and the next one is a TF-IDF vectorizer. So we have these three methods to transform your text data into the vector representation. And based upon the technique chosen, you will get the values populated over these cells. So let me just discuss each and every technique one by one. So what is a binary weight? So what binary weight will do? First of all, let me explain through an example. Let's suppose, guys, we have these three documents. The first document is text mining is to identify useful information. This is the first document. Second document is useful information is mined from text. Third document is apple is delicious. Let's say we have these three documents, and we want to create a vector representation of this particular text data. All right. So as I told you, we have a two arrangement. Either you will get the TDM matrix or you will get the DTM matrix. So can you guys comment it out? What kind of a representation is this, DTM or TDM? We have all the unique tokens over the row side, column side. And all of these documents, like document 1, 2, 3, over the column side. So this is the DTM representation, document term matrix. So if the documents are over the row side, it will be DTM. If the tokens or terms over the row side, it will be the TDM. So in that way, we have the naming convention. Right, it's a DTM representation. Now you have all the unique tokens over the row side and all the documents. So if you are using the binary weight method to transform your text data into the numerical form, so what this binary weight will do, it will either pop up the value 0 or 1 based upon if the particular term appears in the document, the value will be 1. If the particular term is not present in the document, the value will be 0. That means, if you see, the first term is a text. Now tell me, whether this particular term is present in the document 1? Yes, it is present, text. This particular term is present. So that's why we are getting 1. Now, whether this particular term is present in the document 2, if you see in document 2, yes, we have a term called text. That's why we are getting 1. Whether this particular term is present in document 3, no. Text is not present in the document 3. That's why we are getting 0. Let's check for another term or another token. Let's first identify whether this particular term is present in the document 1. Yes, it is present, identify. That's why we are getting 1 here. But this particular token or term is not present in the document 2 or document 3. That's why we are getting 0. So this is how you are getting these values 0 or 1. So if the particular term is present in the document, the value will be 1. It will reflect the 1. And if the particular term is absent, then it will be the 0. This is called as a binary weight method to transform your text data into the numerical representation. But this is not a very optimal or accurate approach when it comes to the real-time problem. So that's why we have a couple of other approaches. And one of the approaches, bag of word approach. It is also called as a count vectorizer. All right. So what this particular approach will do, let's say we have this particular document. So we have a 3 document. This is the first document. This is the second document. And this is the third document. And these are the unique tokens. All right. These are the unique tokens. So the structure will be the same. Either you will get the DTM kind of a structure or DTM. So let's suppose we are getting the DTM kind of a structure that doesn't make any change. So let's suppose we have a different documents present here. Document 1, document 2, document 3. And here we have a different terms, unique terms, T1, T2, T3, and so on. So if you recall the first approach, which was the binary weights approach. So binary weights will update these particular cells either with the 0 or 1. 1 means presence of a term in the document. 0 means absence of the word or term in the document. But bag of word approach, what it will do, it will use the concept of frequency. It will use the concept of frequency. That means the number of times a particular term appears in the document. Number of times a particular word appears in the document. So let me just show you for an example. For the timing, I'm just taking a couple of tokens. So let me just take three tokens. One is a read, another one is a natural, and the third one, let's suppose I have a language. I have these three tokens, and these are the three documents. So document 1, document 2, and document 3. Now, as I told you, this particular approach, bag of word approach or count vectorizer, it uses the concept of the frequency. That means the number of times a particular word appears in the document, that value will get populated in this particular matrix. So if you see the word read, how many number of times the word read appears in the document 1? If you just check here, we have this particular word reading. Well, the base word is a read. So it appears only once. So the value will be 1. In the second document, if you see, we don't have a read. In the third document also, we don't have a word called read. So the value will be 0. Let's check for the natural. In the first word, we have a natural word and it is appearing only once. So the value will be 1. In the second word, also in the second document, the natural term also appearing only once. The value will be 1. In the third document, it is appearing only once. The value will be 1. Let's check for the language. Let me just make it more clear. Let's check the term language. So language is appearing in the first document only once. So the value will be 1. But if you see the second document, the language term is appearing here once and twice. That means 2 times. So the frequency of this particular word is 2. So that's why the value will be 2. Right? And it is appearing only once in the third document. So that means you are getting the frequency that counts the number of times a particular term appears in the document. So this particular approach is called as a bag of word. It is also called as a count vectorizer. Count vectorizer. All right. So let me just take a couple of questions. Don't worry, guys. You will get the attendance link. In between, I guess 8 to 9, we will get the attendance link. Yeah. Yes. Okay, cool. So let me just share my screen again. Okay, so I'm sure my screen is visible to all of you, this Python notebook. Okay, let me show you. Okay, yeah. So this particular approach is called as a bag of word approach or count vectorizer. So we saw 2 approaches. One, the first was the binary weights. The second was bag of word. And let's see the third approach. So there is a limitation with this second approach. I will come back to that particular point, why we need the third approach. As I told you, the first approach is not optimal approach. So that's why we have the second approach, which was the bag of word approach or the count vectorizer. But there is a certain limitation, certain drawback for this particular approach. That's why we have a third approach, which is called as a TF-IDF vectorizer. TF-IDF vectorizer. Now, what is the drawback of the second approach? What is the drawback of the second approach? That means bag of word approach. So guys, if you see the bag of word approach or the count vectorizer, it considers the frequency of a particular term. That means the number of times a particular term appears in the document. But it doesn't consider how important the term is. It will not consider how important that term is. It will only consider the frequency. So that particular aspect is missing in the bag of word approach. The importance of each and every term, that particular aspect is missing. And this particular gap is filled by another vectorizer, which is called as a TF-IDF vectorizer. So out of these three vectorizer, the most preferred and optimum vectorizer is a TF-IDF vectorizer, because it will consider both frequency of the term as well as the importance of the term, how important the term is. Both the things are taken into the consideration when it comes to the TF-IDF vectorizer. All right. So this is what is written here. TF-IDF vectorizer. So this is the backend working of the TF-IDF. I will explain you what are these things. Okay, so let me come back to coding part. Guys, is my notebook is visible to all of you? Yes or no? Guys, don't worry. You will get all these materials over the portal. Don't worry about that. Okay. So let's see, guys, how you can implement these particular approaches. And then I will tell you, like, what is this TF-IDF vectorizer? Okay. So first of all, I will show you how you can implement the count vectorizer, and you can transform your clean text data into the vector representation using the count vectorizer. So this count vectorizer is nothing but it is the bag of word approach, right? So bag of word approach is also called as the count vectorizer. So here I will demonstrate two vectorization techniques. One is the count vectorizer and second one is the TF-IDF vectorization. So guys, under the ExcelR package, so ExcelR is a very useful package in Python. So this particular package is mainly utilized for the machine learning model building part, right? So under this ExcelR package, we have a module called as a feature extraction. Within this module, we have another module called as a text. And within this text module, we have something called as a count vectorizer as a method. So we are importing this count vectorizer method from these modules. And once we have imported the count vectorizer, what we are doing here, first of all, we are creating the instance of this count vectorizer as a vectorizer, but you can skip this part, right? And then with this, whatever instance we have created as a vectorizer, we are using this instance vectorizer with a method called as a fit underscore transform. The method name is a fit underscore transform. What this method will do, it will, okay, so there are two things. First of all, fit and then transform. What fit and what to transform? So apply the vectorizer, which is the count vectorizer. Just apply the vectorizer, that means fit the vectorizer over this book data set, and then transform this text data set into the numerical form. So that's why we have this function called as a fit underscore transform. And you can utilize any of the function in Python using the dot operator. Right? You can skip this particular like instance creation part. You can directly use here, instead of vectorizer, you can directly use here count vectorizer. You can skip this part and directly use here count vectorizer. That also be a one approach. Okay, but this is the like most preferred approach. So what we have done till now, we have applied the count vectorizer over my book data set, and we have called that transform this text data. And the output is saved in a variable called as a bag of word matrix, BOW matrix. So let me just show you what this matrix contains. So I have just converted this matrix into the array form so that you can visualize in a much more clear manner. And this is the array what we are getting after applying the count vectorizer over the book data set. Let me just show you what was my book data set. So this was my book data set. This complete all the reviews, all these documents. This was my book data set. So with respect to this text data, this is the vector equivalent or numerical equivalent data set I'm getting here after applying the count vectorizer. This is the vector representation of this text data. And if you see here, we are getting value either 0, 1, 2, and in the numerical like integer numbers. So what are these numbers? These numbers are nothing but the frequency of a particular term. Right? Obviously, yeah, here you can't see the like rows or column names because it's an array form. But we have a different methods available through which you can extract the rows and columns also. You can also see what are the your unique tokens and what are your rows or columns. If you want to check what is the shape of this particular array, which is in like matrix form. So you can check the shape of this particular array, and the shape is, guys, 40 cross 1010. Now, can you guys tell me, out of these two, how many number of rows are there and how many number of columns are there? You can write your answer in the chat box. Can you guys tell me how many number of rows are there and how many number of columns are there? Exactly. So we have a 40 rows and 1010 columns. So you can see like see here how big this particular matrix is. There are 40 rows. Why 40 rows? Because we have a 40 documents only. If you see here, and if you recall, originally we have only 40 documents, 0 to 39. That means 40 documents. That's why we are getting the 40 rows. But over the column side, we have a unique tokens. And based upon this text data, there are 1010 these many unique tokens. So that's why we are getting these many columns. So this much big matrix we are getting as a numerical representation of this book data set. Right? Okay. So this was the approach of bag of word, how you can use it. It is also called as a count vectorizer. And this is what you're getting the numerical representation. Let me just discuss you the third approach, which is most optimal approach out of these three approaches, which is a TF-IDF vectorizer. And as I told you, like this kind of a vectorizer is overcoming the limitation of the count vectorizer technique. So what was the limitation with the count vectorizer? The count vectorizer will only consider the frequency of a term. It will not consider the how important a term is. So that's why we have a third kind of a vectorization technique, which is called as a TF-IDF vectorizer. So in the TF-IDF vectorizer, we have two terms. One is a TF, which is called as a term frequency. We have another term, IDF, which is the inverse document frequency. So we have these two terms. The first term, which is a TF, that means term frequency, it will take care of the frequency part. That means what is the frequency of a particular term. The second part, which is an inverse document frequency, this particular part will take care of the how important a particular term is, the importance of a term. So in that way, we have the combination of both frequency as well as the importance of a particular term. right? If I talk about how mathematically they work at the backend, so for that we have a formula associated for these two terms. So to find out the term frequency, we have a formula called as a number of times a particular term t appears in a document divided by total number of terms. It's a simple how we find out the frequency of a particular term. It's a simple way. The number of times a particular term appears in a document. This is the term frequency. And to calculate the IDF part, that is the inverse document frequency, the formula is log of total number of documents divided by number of documents with the particular term t. All right? The number of documents with a particular term t. So in that way, we will be getting two numbers here. One is a TF, another one is a IDF. And the final value is nothing but it's a multiplication of these two values. So TF multiplied by IDF, that is the final TF IDF number. And it has been said that higher the TF IDF value, more important the term is. Right? So this is how you can calculate that TF IDF value for any term present in your document. Let me just explain you through an example how you can get the TF IDF value for a particular case. So guys, here I have considered, let's suppose guys, we have a document containing 100 words. And out of these 100 words, there is a particular word called cat, which appears 3 times. This is first thing which is given. Another thing is given that, so this is with respect to a particular document. There is another information given to you. Let's suppose you have a 10 million documents. That means the corpus size is 10 million documents, right? So there is a one corpus, and in that corpus, we have a 10 million documents. And the word cat appears out of 10 million documents, only 1,000 documents. So out of 10 million documents, the 1,000 documents are there for which there is a word called cat appears. This is the second information. So you have a two information. I'm repeating it again. You have a corpus. In that corpus, you have a 10 million documents. 10 million means 10 into 10 to the power 6, right? It's a 10 into 10 to the power 6. That's a 10 million. And out of these 10 million documents, 1,000 documents contains a particular term called cat. This is the one information. Another information is given as there is a particular document which contains 100 words. And out of these 100 words, a term cat appears 3 times. So these are the two information given to you. And based upon these two information, you can find out what is the TF-IDF score for a particular word or token called cat. So for that, you need to calculate two things. One is a TF, which is a frequency term. And the second one is a IDF, which is a importance term. So how you can calculate the TF? So TF is being calculated like number of times a particular term T appears in a document divided by total number of terms in the document. So this thing is being calculated with the help of this information. A document contains 100 words and the word cat appears 3 times. So TF is nothing but the number of times a particular word cat appears, that is 3, divided by total number of words in the document, which is 100. So the value will be 0.03. This is the value of the TF. Then what is the IDF? IDF is nothing but it is the log with basic, log of total number of documents. So in total, we have a 10 million documents divided by number of documents with the term T. So how many documents having the term cat? So there are 1,000 documents divided by 1,000. If you solve this one, you will get value 4. So what is the final TF-IDF value for a term called cat? So for cat, the final TF-IDF is 0.03 multiplied by 4. That is a 0.1. This is the final TF-IDF value for a term cat for a particular document. So this is the value what you will see in the DTM or TDM matrix. And this is how TF-IDF works at the backend. I'm sure it is clear to all of you guys, right? So this is the backend processing of the TF-IDF vectorizer. Let me just show you how you can apply this particular concept in the Python. But before that, let me just take a couple of questions. Okay. So guys, attendance link is shared to all of you guys. Okay. Great. So let me share my screen. Okay. I'm sure my screen is visible to all of you guys. Let's see, guys, how you can implement the TF-IDF vectorizer over your text data. So the method is and the approach is exactly same how we have done with the count vectorizer. So under the ExcelR library, we have a something called as a feature extraction module. Within this module, we have another module called as a text. Within this text module, we have a something called as a TF-IDF vectorizer as a method. So first of all, we are importing this particular method TF-IDF vectorizer. And then we are creating the instance of this particular method as a vectorizer underscore TF-IDF. Now, the thing is exactly same. We are applying this particular vectorizer over my book data set, and we are using the method called as a fit underscore transform. That means, first of all, fit or apply this particular vectorizer over this book data set, and then transform this text data into the numerical representation. And once you get the transformed representation, let me just show you how it looks like. So this is what you are getting. Now, if you see the value present in this particular array or matrix form, these are some decimal values. So these values are being calculated based upon the TF-IDF formulas, what we have discussed just now, right? So for each and every token or term, it will calculate the TF, it will calculate the IDF value, and finally, it will multiply these two values to get the final TF-IDF value. So this is how you can apply the TF-IDF vectorizer to transform your text data into the numerical form or the vector representation. But before applying this kind of a technique, make sure you have gone through all the data pre-processing part. That means you have removed the stop words, you have removed the punctuations, all the any kind of a special characters, you have removed all those things. You have done with the lemmatization, those kind of things. That means these kind of techniques are applied over the clean text data. Right? So this is one thing. Okay, that's the question. Attendance link is already shared in the chat box. You can find it out. Okay. What if someone directly jumps into the TF-IDF method? What do you mean by the directly jumps? I mean, do you want to directly apply the TF-IDF over your raw text input data? If that is the case, it is not the right approach. Okay. So you need to go through all the data preprocessing part. And once you get the clean text data, then rather than applying the bag of word or binary weight approach, then you can directly use the TF-IDF vectorizer. All right. Guys, please don't share your screen. Okay, thank you. Yeah. So please. So guys, data pre-processing step is compulsory. You need to go through that part, right? And whatever data pre-processing steps or concepts we have discussed, all these concepts are applicable over the text data only, not over the numerical data. For numerical data, we have a couple of other concepts. All right. Okay. Let me share my screen. There is a one more very interesting part is there with respect to the NLP. Okay. So guys, there is something called as a word cloud. There is something called as a word cloud. I'm sure my screen is visible. This Python Jupyter notebook, right? So there is something called as a word cloud. What is this word cloud? Before that, first of all, you need to install this particular library, word cloud. And how to install? I have already discussed how you can install any of the package in Python. So what you need to do, just remove this hash sign and run this particular command. It will get installed in your system. So hash sign is nothing but this. It will make the code as a comment. So if you are putting the hash sign before any of the line, your code will become a comment. It will no more will be a code. So to make it a code again, you need to remove the hash sign, right? I'm sure many of you guys know. Now let's see what is this word cloud. So word cloud is, guys, very interesting concept in NLP. It is a kind of a visualization. First of all, let me just show you what is the visualization. So this kind of a visualization you will get from the word cloud based upon your input data set. So here my input data set is a book data where we have a number of reviews for a particular product. Right? In total, we have a 40 reviews. This kind of a visualization you will get if we are using the concept of the word cloud. So what is the word cloud? It will show you the words which are more frequently occurring in your text data. The words which are more often present or more frequently occurring in your text data, it will show you those words. And if you see, couple of words are with a very large font size, couple of words are very small font size, right? So that is totally depends upon what is the frequency of that particular word. So like in this particular text data, I have a word called good, which is appearing most of the times, or product. If you see the size of this product, good or Mac or year, warranty, these are the words which are more often or more frequently appearing in my data set. So you can visualize, you can get a visual representation of those tokens or those words which are more frequently, more often present in your input data set. Right? It will give you a very, very clear-cut idea what are the important tokens are present in your data set which are more frequently occurred in your text data set. Now, how you can get this kind of a visualization? So as I told you, for that, you need to install a package called as a word cloud. Right? So from this particular package, word cloud, there is a function called as a word cloud. With the same name, we have a method, and we are just importing this particular method called as a word cloud. Right? And then here there is some arrangement. So you can add a couple of words as a stop word list. That is something I have already discussed. So here what we are doing, we are just using the word cloud method. And in that method, what you can do, you can adjust the size of this particular visualization. That means how much will be the width, how much will be the height. Even you can also control how many number of words will be there in this particular visualization. You can pass here 10 words or 50 or 100 or 200. It totally depends upon your need. You can control how many total number of words will be there in this visualization. And then it will give you an option called as the stop words. If you pass the list of stop words here, it will automatically remove all the stop words from your input data set. And then you need to use a method called as a generate. How you can use? Using the dot operator, dot generate, and in that you need to pass your text data. Okay. So here I have passed my text data. So this text is a variable where I have all these reviews. Right. So in that way, you can use this word cloud and then just show. You can use the IM show method to get this kind of a visualization of your text data set. Right. So you will get. So here I have used maximum 100 words. So that's why I'm getting only 100 words in this particular visualization form. And the size of word will tell you how often, how frequent a particular term is present in your text input data set. Right? So this is something called as a word cloud. It is a cloud of words. Right? So you can easily get an clear-cut idea what are the most frequently of appearing words or you can say terms are there in your input data set. So this is the utility of this word cloud. I hope this part is clear to all of you. You can also save this particular visualization as a PNG file or in some other format in your local system. Right? And where it will get saved in the same folder where you have this particular Python notebook. Let me just tell you, show you a few more things with respect to this particular Jupyter environment. Guys, this is the Jupyter notebook. And in this notebook has a name as a NLP1 text processing. You can change the name of your Jupyter notebook. Just click here and you will get the rename notebook. Here you can pass any of the name which you want to give for this particular notebook. Let's suppose I want to rename it here, NLP1 text processing plus word cloud. And just press over the rename, it will get renamed. So your notebook name will get renamed. So in that way, you can change the name of your notebook, Jupyter notebook. All right. You can add any of the cell using this plus button. Even you can delete a cell using this scissor button. Right. So let's suppose I have a cell like this, and I want to delete this particular cell, this second cell. So just press anywhere the cursor over this second cell and click on this scissor button. So that particular cell will get removed. You need to take care of using this particular button, because once you remove any of the cell, once you delete any of the cell, it will not get returned. Like you don't have an option of undo here. Okay. You can, there is one more important facility available under this Jupyter notebook environment. You can run all of the cells in a single go. How? Just click over this cell option and you can see here, run all. If you click this one, each and every cell will get executed one by itself. Right? So in that way, you can utilize this particular notebook. And this Jupyter notebook is having the extension of IPYNB. This is something, these are some very basic things you guys need to know. If you save this particular notebook in your local, you can see that there is a extension for this particular notebook is as a IPYNB. That is the interactive Python notebook. Interactive Python notebook. What is the extension? So if you save any Excel file, let's suppose there is an Excel file called as the ABC. So what is the extension for the Excel file? .excelSX. This is the extension for the Excel file. For CSV file, the extension is a CSV. .csv. Just like that, the Jupyter notebook is having the extension of .ipynb, which stands for the interactive Python notebook. Right? So these are some minute details which are very important when you start working with this kind of environment. So guys, this is all about from my end with respect to the NLP introduction and overview. I guess I have covered a lot of things, so that you guys get familiar with respect to all of these things, these terms and the techniques, whatever we have discussed. Meanwhile, let me just take a couple of questions. What do you mean by how to open the previous classes? You want to ask like how to open any of the Jupyter notebook? Okay, let me just show you how you can open any of this Jupyter notebook. Okay, guys. So once you have installed the Anaconda distribution, and once you open the Anaconda navigator page after installing and downloading and installing this Anaconda distribution, once you open the Anaconda distribution, you will get this kind of a home page. In this page, you will get different kind of platforms, different kind of tools are there, like Spider, R, Jupyter Lab, Jupyter Notebook, PowerShell, IBM Watson, and so on. What we are using this Jupyter Notebook. So how to open this one? Just click over this launch button. Just click over this launch button. It will automatically get open in your browser like this. So over the browser, you will get this kind of a home page where you can see you have a desktop icon, you have a documents, you have a downloads button. So these are the, this Jupyter is linked with your local system. Here you can navigate to the respective folder where you have saved the Jupyter notebook or where you have saved the codes. So let's suppose under this desktop, I have a folder called as a ExcelR. Within that, AI ChatGPT training program, another folder, and within that, day 3 folder. So here I have this particular Python notebook, and just the moment when you click over this Python notebook with the extension of ipynb, it will get open like this. Right? So in that way, you can navigate to the Anaconda navigator. Okay, so if you are facing issue with the limits in the Zoom meeting, so probably you can join with the YouTube link. Anuradha, percentage matplotlib inline, it is a command. I'm not sure whether you guys know matplotlib or not. So actually matplotlib is a library which is used for the visualization purpose. That means you can use this particular library to get the plots. And this particular line is used to save the plots once you close the notebook. So if you are executing this particular line of code percentage matplotlib inline, and let's suppose after this, you have done a couple of plotting or visualization, and you close your Python notebook for today. And tomorrow, when you open your notebook, you will get all those plots appear without running the notebook. Like without executing the cell, you can see all those plots. So that is something done by the percentage matplotlib inline. Thank you, Alpati. Thank you very much. So Srisha, lemmatization and stemming both like the working is little bit different, but the idea is same. So it's like lemmatization is something which will convert your words into its root form, like amazing to amaze, running to run. Run is a root form, right? Running is not the root form. So this is done by the lemmatization. And stemming will only remove these suffixes like ing, es. Doesn't, it will not take care whether after removing the suffixes you will get the root form or not. Yeah, like it's over for today. So tomorrow, guys, tomorrow's topic. You guys are asking for tomorrow's topic. So tomorrow I will start with the basics regarding the deep learning and AI. And probably tomorrow and day after tomorrow, these 2 days, we'll be dealing with the basics of the deep learning and AI part. So over to Amar, if you have any announcement or
Yeah,
any
sure.
message.
Thank you so much. So, dear participants, any query, any question, please let me know. Attendance link, yeah, I'm sharing once again in the chat box. 1 minute. Yes, guys, I'm sharing that 1 minute. Yeah, sure. Please mark your attendance and share your feedback as well. So there is one question: how many days program is there? So it will be 7.5 for 15 hours, 2 hours per day. So guys, if the code is there or practice file is there, Excel file is there, now then you are able to download. For PPT, you have to go through LMS only, okay? So please visit the LMS, you will get the perfect idea about all the material. Last class, I don't mark the attendance, okay? But for today, we don't have any option for that. Are there, 1 minute, are there program like these that are going to on live? If not, will there be some more soon? Yes, we're planning for the same. And on the last day, definitely we share that information about the upcoming programs as well. So guys, don't worry about that. We used to launch 3 to 4 program every month. So we'll keep updating you. Okay. So one more question. Yesterday and day before yesterday classes, can we watch? Yes, you can watch through the LMS. The recording will be there with you for lifetime. YouTube people, I know you're enjoying the session. If you're really enjoying the session, I need one like from all of you. One quick like. You're welcome, all of you guys. 7.5,000. Amazing lecture. This is a wonderful session. You're welcome. Thank you for beautiful session, sir, and more excited on tomorrow's topics. Good night, sir. Good night, guys. Good night, all of you. Yes, guys, if you don't have any query or question, we're done with the day. You can leave the session and we'll meet you on tomorrow at the same time. Sir, you are the host, so you have that option in the settings so that other participant can't share their screen, only host and co-host can share. Yes, I know that, but it's disabled from the backend, so I'm not able to do anything. But it's okay, no one is going to share the screen. Rest of host and co-host, okay? So there is one question. Is there any test in the course? So guys, there is a no need assessment, but you will get the assignment for practice purpose. You need to submit that assignment as well. Okay, then I think there is no more questions. Yeah, sir, no problem. We'll take care of that. Thank you for suggestion. No, there is no any merit for the certificates. Okay, guys, then thank you so much for joining the session. And we'll meet you on tomorrow on day 4. Bye bye. Good